I'll just do it. I have one chance. One chance. One opportunity to have a basketball dream of my life. I have to make this. I have to do this. This is all I got. I have everything I know, everything I'm gonna do is on this. All right. You and me, let's go. All right. Now, these are the rules. All right. First of all, you can't trespass. Second of all, you can't do line drives. Okay. Here we go. I'm gonna check this to you, and then you're gonna have to make a basket. Right? Go for the lion. Or I'll go for the vultures.
I'm lion.
Woo! Vultures. Here we go.
Here we go.
All right.
Okay. Go.
Oh, wow. Oh, you're really good at that. Okay, wait. I just remembered. Is it 1 o'clock? Don't you have a class or anything?
No, I'm good for 30 minutes. I can play.
Oh, but my class. Oh, my class is here. Oh no. You need?
Good.
Guys,
Good. Yep.
Sure?
Yeah.
Okay. All right. Love you.
Bye.
Bye. Get your class. Oh, I'm at the class. Okay. Here we go. All right, guys. So this is the deal. Is this? Oh, okay. It's chemistry class. All right. Here we go. You guys ready to do some chemistry today? Because I sure am. All right. So let's do this. So first of all, we had our equation or our paper yesterday, and when we did that, yeah, I'm going for both teams. Remember, I'm a spectator around here. All right. So yesterday we had pages 256 to 257. Number 1 says this. What is a conjugate base of H3PO4? Well, obviously, if we're going to make a base, we're going to have to take away an H, which the more H's that we have, the more acidic the environment is going to be. So therefore, it's going to be H2PO4. Number 2, what is the conjugate acid of NH3? Well, we're going to add another H to make it that conjugate acid. So NH4 is going to be the correct answer for that. Write the net ionic equation. We're going to have NH3 in a gaseous formation plus H aqueous. Eventually, that's going to equal NH4 in our aqueous solution as well. Our next equation, HCl plus NaOH, equilibrium sign, NaCl, aqueous solution, plus O2, or H2O in our liquid form. We're going to have H in our aqueous form plus OH in our aqueous form, and then that's eventually going to equal H2O in our liquid form. Number 3, for our problems that we had on our worksheet yesterday, Mg plus 2 HCl in our aqueous form equals MgCl2 aqueous form plus H2 in our gaseous formation. That net ionic equation is going to be Mgs plus 2H aqueous solution there. Mg, that's 2 positive for that charge in aqueous solution. H2 in our gaseous form. Our last one, I'll just go through the answer real quick because we need to get into today's lesson here. HO3 aqueous solution plus 2H aqueous solution equals H2O liquid form and plus CO2 gaseous form. Yesterday, before we ended, Darcy actually had a great explanation of why in the world for CO2 and CO3 at that last equation, why don't you cancel those out? Well, first of all, CO3 is an aqueous solution. It's dissolved. It's not, well, not necessarily dissolved, but it's broken up. We're putting it in our net ionic equation, so we have to put in our complete ionic equation. So therefore, that's in our aqueous solution. CO2 is going to be in our gaseous formation as well, which I'm kind of looking at that. I think that's supposed to be CO3 on both sides. I guess I didn't do that for the last one, but that could be another example if it's missing an oxygen molecule right there. However, we need to continue. Hopefully you guys got that correct. Please upload it by 3 p.m. today. That's when I'm going to be grading it. If it's not there, boom, I'm putting a late sign on it, and then you're not going to get credit for that because 60% of your grades are in all these worksheets and stuff. This starts today. Probably shouldn't be showing that. However, we'll still continue talking about our acids and as well as our bases, of course. We have this game going on. The Vultures versus the Lions. You saw Mrs. Taylor today, and we were playing, and we were seeing how the entire games were going. So here's the deal. We need to talk a little bit more about what's going on with the acids and bases that we have here. So here we go. We need to talk a little bit about bases, of course, but salts. Now, salt is kind of an interesting idea here. First of all, when we go through a reaction and we're going to get a salt and water. So anytime we put acids and bases together and we get a salt out of it with water, that's called neutralization. So number one, it says here, what is the term for the reaction between acids and bases to form salt and water? Well, that is going to be called neutralization. That's very important for you guys to understand. Number two is going to help us. It says this, what is composed of a cation except H positive and an anion except O negative? Guys, let's think about this, okay? So first of all, NaCl, we already know what NaCl is. So NaCl. Notice something here. We're missing a few things. We're missing a proton, which is H positive, and we're missing a OH negative, which is what we're talking about. We've been talking about our acids and bases. If chlorine right there has hydrogen with it, it's going to be an acid. If Cl had an OH, ClOH, it's going to have it's going to be a base, of course. However, in this equation, we don't have a proton, we don't have a hydrogen, we don't have an OH to it. So therefore, the NaCl will be a salt. Number 3 says sodium chloride, which is up here, is the only salt that exists. Man, I hope you guys understand this. No, that is not true. That is not the only salt that exists. We also, if you guys remember doing our lab when we dealt with potassium, I believe it was KCl. We had KCl for that example. On our page on 255, you can actually look at all the salts that we have here. It says on table 15.5, sodium chloride, there's our salt. We have sodium fluoride, potassium chloride, there we go, potassium chloride. We also have potassium iodide, potassium iodate, magnesium bromide. So all of those equations, if they do not, I repeat, if they do not have an H positive, if they do not have an OH negative, they're gonna be salts. So make sure you guys understand that. It's very important. So kind of going through this idea here, that's, if you guys remember when we dealt with our equation, trying to get out here, hold on, where is it? No, I think I might have lost it. When we had that equation dealing with H positive, or H with hydrochlorine, H, capital H, capital F. Does anyone remember that? Hold on, raise your hand if you do with that equation. Maybe some of you guys don't. Where did that paper go? For some reason I'm missing that paper. Ah, here we go. So when we had this equation, when we had HF plus KOH equilibrium, H2O, and then KF. Notice that equation right there. Actually, I want to draw that on the board for you guys here. So HF plus, I won't put the abbreviation stuff to it, KOH, all right? And then we have our equilibrium sign right here. Then we have H2O, and then finally our K, what was that? K, in our formula right here. All right, so notice something here. We've already talked about this when we have an acid and a base. So here's our acid, here's our base. And if we have an equation where we produce water and we produce a salt, we are going to have this neutralization reaction happening. And that's pretty much what we're going to be talking about today. Not only that, soluble salts definitely dissolve 100% into ions in their aqueous solution. So that really helps us with writing our net ionic equations, because when we do have those equations that happen, then we're able to put those in our net ionic equation as well as in our complete ionic equation as well. Activity series is kind of interesting because when we put salts with each other, some are going to be a little more reactive and some of them aren't going to really be as reactive. Usually when you go closer to the left side of the periodic table, it's going to be more reactive, I guess you could say. If you go further right, it's going to be less reactive. So notice this on page 256, which is what we're going to be studying here today. We have a very activity series of selected metals. We have lithium, potassium, calcium, sodium, magnesium. Notice that they react with H2O. Notice magnesium, aluminum, those react with steam. And then notice the very bottom, copper, Cu, and mercury, Hg, Ag, and Pt. Those all don't really react with acids. So the further we get down that chart, or further to the right we get, they're not going to be as reactive. So that's activity series. I have a good picture for you guys also on this page when we have a zinc strip reacting with hydrochloric acid solution. Notice we see copper there. Now let's see if we can find that zinc strip on this activity series right here. Let's see, it looks like between aluminum and chromium, we're going to have Zn right there. That's zinc. All right, so put your finger on that zinc right there, and then we need to find that copper. Copper, we already know the elemental symbol for that is Cu, capital C, small case u. So let's find that. Oh, we notice here that the Cu is below zinc, so therefore it's going to be less active in this activity series. I hope you guys kind of realize that. Next thing we need to talk about, I thought about putting this idea, well, I need to get my eraser. So I thought about putting this idea in, how do I explain this? In my worksheets here, but you know what? I thought about just giving you these equations right here. Every time I bring up equations, I know you guys are like, I don't really like equations, but no, they actually are very helpful for you guys. So this is kind of what we're going to be working through today. The equivalent mass. So sometimes we're going to have to figure out what the molar mass is compared to the amount of acids that are in a certain solution. And then we have an equation for that. So the equivalent mass is going to be the molar mass of an acid or a base. And then we're going to have a number of ionized H atoms divided by that. So let's look at kind of an example for that. So number 9, it says that here, H3, we have H3P O4. All right, so we have H3PO4. Now, is this an acid? Shake your head if this is an acid. I see no one shaking their head. They're all staying still. Like, whatever you, I don't know who keeps their heads. Owls, okay. Chloe, we're doing this half thing. Which one is that? Oh, okay, it is. Okay, all right, yes. It's an acid because it has this hydrogen right here. Since it has it with it, it's going to be an acid. Very good. Excellent. So we need to talk about what the equivalent mass here is of potassium. So PO4 negative. So here we go. Let's talk a little bit about that. How are we going to find that? Well, first of all, let's look at our equation. What does our equation tell us? It says the equivalent mass is the molar mass of the acid or the base. So we're dealing here with an acid, of course. Notice that we're not going to add the H's because that goes on the denominator. So we're going to find the molar mass of an acid. Hopefully you guys still have your worksheet I gave you, this plastic folder here, because we're still going to find molar masses in chemistry. Even in the 4th quarter, can you believe it? We're still using that example of when we go to the mole, we're going to have to divide our profits. When we go away from the mole, from, I think it was Avogadro's number or something like that, we're going to multiply our profits. All right, wait, no, that's going to deal with if we go from the mole to grams or to atoms. All right, so here we go. So first of all, we need to find the molecular mass here. So we already kind of know potassium right here. So 30.97 grams per mole. We have oxygen. There's 4 oxygens. Wow, that is a plethora amount here. So 16.00 grams per mole right there. All right. Let's see. Hopefully you guys have your calculator. Some of you probably have forgotten it at maybe here or something. And for some reason, I don't even have my calculator. That's kind of strange. I shouldn't be doing that as a chemistry teacher here. So we have 16 times 4. That's wrong. 16 times 4, 64 there. And we're going to add 30.97. Our molecular mass is 94.97. So all this, let's add this up, guys. 94 point. I almost forgot. There we go. 97 grams per mole. All right, we're going to use this for our equivalent mass equation. Notice we're going to have the molar mass of the acid or base. We're dealing with an acid here. And then we're going to divide it by the number of ionized H atoms. So in this equation right here, how many ionized atoms do we have here? I'm going to mute someone. How about Darcy? How many do we have here? 3. Let me take a look. Yeah, there you go. Very good. So we have 3 right here. So therefore, we're going to take our molar mass and we're going to divide it by the number of ionized H molecules. So I'll move over here to this right here. So we have 94.97, and then we're going to have 3. Now, kind of interesting when we're dealing with this, if you notice, I'm kind of taking these examples from page 257. They say here that the ionized molecule right there is in fact our equivalent mass of EQ over moles. So we're going to have EQ over moles, and this is going to be grams per mole. When we divide this out, these are going to cross out, and then we're finally going to get our answer, which is this answer plus our grams per equivalent mass right there. And that's what they wanted us to find. So can someone divide this for me? I'll divide it real quick here, see if that's correct. Who can help me with this? If someone raise their hand or something and say something. Anyone at all? Mrs. Taylor is taking pictures of me, so I'm trying to pose. No, not really. All right, Anaya, yes. Very good. We just found, let me see, 31.66. I believe that is the proper, yes, there we go. All right, so excellent. So there is our final problem that we see right there. Does that make sense, guys? Do you understand that? Pretty simple. Okay, excellent. So let's see here. All right, let me get organized real quick. All right, fantastic. So let me look. So here's another deal that we have here. Number 8 says normality. Oh man, we got another one of these. Molality. What are the other ones we had? Molality, molarity. There we go. So all those. Now we have normality. So I was kind of looking through this. Kind of interesting. Notice what it says. It says equivalent solute. So we pretty much just found the equivalent solute in this, which was this right here. Let me start going for it. This is the equivalent solute for each ionized H molecule atom that we have here. Notice that it's divided by liters of solution. So kind of interesting. If we have a solution, for example, such as 5 liters or something, we're going to divide this whole thing by 5 liters, and that's going to give us our normality. I looked through our tests, and they have nothing about normality, and I'm like, what in the world? Why would we cover this and not have it? So therefore, the only thing I want you to know is just really the equation. If we do come across either in a quiz or something, it might be merciful to go with you guys in order to handle that. All right, so here's the next idea here. Actually, that's pretty much it for the day here. But first of all, homework before we leave, guys. It says this. What does EQ stand for? And find the equivalent mass for BaOH. Notice that OH is a base. So we dealt with an acid up here. So make sure you guys notice the difference between that. If you guys have any questions, stay on the line. If you don't, we'll see you guys later. Have a great rest of your day. It's a weekend, so find something cool to do. We'll see you guys later. I'll just keep waiting until you guys go, unless you guys have a question. Yes, Jeremy, I will unmute you. Yes. Hold on. Oh. I think you have to. There you go. Okay. Uh-huh. Okay. Can you take a picture and upload it? Okay. Try that, and then if it doesn't work, get back with me so we can have your stuff. Okay. Okay. We'll see if you can take a picture. Maybe try uploading it because I know I saw it. And I think I might have erased it. So I think you have to upload it again. Yeah. Okay. All right. Oh, sorry, Jeremy. I just muted you. What's that? Okay, very good. Okay, so Jessica, yes. For the homework for today, last night's homework. Strange. So that was over, what pages was that over? 251 to 253? No. 254 to 255. Okay, so Jessica. Yeah, so I just put wrong document. So if that happens, I probably just erased the file. So you might have to upload it again. Strange. Can you refresh your page and see if it works? All right, I will come back to you shortly. Anaya, yes, question. Second homework question. All right, so the conjugate asks. There it is. So we have NH3. All right, so the only way for us to make it an acid is that we have to add an H to it. So therefore, it's going to be NH4. That makes it acidic. Find the equivalent next. Oh yeah, Ba and then parentheses, then OH. So you're going to find the molar mass of Ba and then divide it by 2 because you have 2 OHs. Pretty simple. All right, excellent. Jessica, yes. There's no but. Have you talked to your classmates? Because it's right. Wrong document. Okay, so I think what happened with yours is that, first of all, it's going to be, the worksheet's going to be review pages 254 to 255. It has to say review 254 to 255 because the previous one that we had was over pages 254 to 255, but the one I just uploaded was a review for page 254 to 255. Does that make sense? Okay, so we need. Okay. Have you tried to take a picture of it and upload it? There's no button. That is really. Okay. Okay, we can do that. Or what I could do, I could just write in the comments my email for school, and then you can just send it there, and then maybe that can work too. All right, so we have. All right, so I'm gonna save that. So if you can't upload it, try to email it to me. So I put in the comments my email for you, my school email, so that you can send it there if that doesn't work either. Does that make sense? All right, are you all set? All right, well, we'll see you later. Have a great rest of your day.